Hi, I'm Chet Haas, an engineer on the Android UI Toolkit team. Today I'm going to talk about a new animation feature in the KitKat release. It's called transitions. So the idea with transitions is actually the idea behind a lot of the stuff that we do, which is trying to make things easier for you, the developers of Android applications, to get richer experiences for your users, hopefully with less effort. Transitions, it's kind of a simple idea. It's basically a way for you to describe the different scenes in your application, either beforehand as layout resource files or dynamically as things change in the application, and then use transitions to animate the changes no matter what those changes were. And you can step out of the way and just let the transitions run automatically without having to get more involved and run these manual animations, which are more of the typical model of animating things in a UI. Hopefully at the end of the day, you get richer applications experiences by having more stuff move on the screen in an intuitive way. Your users get richer experiences and they get a better understanding of how your application actually works because you can transition naturally between these different scenes of your application. And there's more animations in the world, which I'm always in favor of. Okay, so let's take a look at some slides and we'll go over a very quick overview of how the API works, what the different pieces are. There's a lot of details that I'm skipping here. But you are free and encouraged to check out the details in the reference docs and articles on developer.android.com, and also API demos, which we'll see a little bit later. We'll take a look at some code in that. Okay, so first we start out with the idea of a scene. You can think of this as a layout. It's basically a view hierarchy that describes what this particular scene looks like. This could be the scene of the entire application in a particular screen, or it could be some sub-hierarchy. In this particular case, the scene describes this situation where we have a text view, an edit text, and a button. Fairly simple. And then we have another scene that we've described through possibly some other layout file. We have different text views in there, a little bit richer text, longer details there, but we have, again, an edit text field and a button, and maybe these are shared components. Maybe they moved location, possibly changed size, but they're actually shared between the two scenes. Wouldn't it be nice if you could help the user understand as they move from scene 1 to scene 2 in your application the changes that had occurred by fading things out that go away, fading things in that have come into being, and moving and resizing the shared elements between these scenes. That's what transitions are about. You specify these different scenes, and then when you go to a scene, the transition automatically kicks in and runs the necessary animations in order to make that change as well as to animate the change over time. So let's take a look at scenes. These are the modules that you've defined for your application, the different screens, if you will, of state that your application will move through over time. You can just construct these scenes in different ways. First of all, scenes always have a root or a view group associated with them, which is basically the hierarchy under which the scene lives and in which transitions will take place. So you can construct a scene directly with that root, and then you can set an enter action, and whenever that scene is entered, you will get a callback into your runnable, and you can run whatever code you want to make whatever manipulations you want to the view hierarchy. Fairly straightforward, a little bit more manual than the other ways you can create scenes. For example, you can create it from a view group instead. Let's say you have inflated a hierarchy from some layout ID, you have this view group sitting there, you can create a scene with that view group. So you give it basically two view groups. You can create it with the root of the scene hierarchy, as well as the root of the scene itself. So you pass that in, you've created a scene, you're good to go. So now when the scene is entered, it will simply change the scene to be looking at that view group instead. You don't need to tell it what to do to manipulate the hierarchy. It gets that information from the view group that you passed it in the constructor. Finally, we have something very similar to the last one, but instead of handing it a view group, you hand it a layout resource ID. And when that scene is entered, it will inflate the resource and it will go ahead and add that to the scene root. Straightforward. The layout resource also kicks in if you create scenes implicitly in resources, which we'll see a little bit later. You can have a transition manager that automatically inflates scenes implicitly given layout resource IDs, and it uses the same mechanism under the hood. Next, we can take a look at transitions. These are the engine responsible for declaring what it is you want to do when things change from scene to scene in your application. So these basically listen for changes before and after, and compare those values, and then based on changes that occurred to any view in the scene hierarchy, they'll create an animator that then gets run to animate those changes. There's a few different ways to create transitions. You can just create these things directly. We have some defined in the framework already. There's a change bounds, which will move and resize objects that change between scenes. There's a fade that will fade things in and out according to whether they come or go between scene changes. And then there's also a transition set, which is kind of the transition equivalent of animator set. It's basically a group. It's a way of choreographing several different transitions. You can create a transition set and then tell it to whether for all of its transition children to run those together or sequentially. And it can also be a hierarchy of sets, so you can have a much more complicated mechanism that runs several transitions, in parallel or one after another to get a more interesting animation experience. And finally, you can load transitions from resource files. If that's the way you go, if you want to run it from resources, this is how you can do it. You can, this one, for example, is a transition set that gets loaded that has 2 children automatically added to it to listen for changes in visibility as well as size and location. The resource file, maybe it's not something you want to do from code because you're already in code and it's easy enough to create these things on the fly. On the other hand, this is the mechanism that is used by Transition Manager when it inflates a graph of information, which we'll see soon, but not on this slide yet. Finally, there's an idea of custom transitions. So we've defined, as I said, a couple of canonical transitions which automatic transitions will use on the fly. There's change bounds, which moves and resizes views, and there's also fade, which deals with visibility information, fades things in and out. Fairly straightforward, probably the behavior you want in most cases. But if you want to define your own transition, for example, if when something comes into being, you didn't want it to fade in the middle of the screen where it lives, but you actually wanted to slide it in from the right, then you can write a custom transition. You would simply subclass the transition class itself, and then you override the 3 methods that do what it is you want to do. There's 2 capture methods. One captures the values at the start when the application code said, okay, I'm ready to do a transition. That's the point at which you would get a call to your capture start values method. And you would go ahead and just read from the view objects anything you wanted to that affected your transition. So you could read the layout position, for example, or the visibility information that you care about. And then you get a call to capture end values when the transaction actually wants to run, when it wants to start. And then you finally get a call right after that to the create animator function, which can then compare those values and say, okay, well, this visibility value changed and that's something that I care about. Therefore, I'm going to create an animation that does the following, slides in from the right or whatever it is. Returns that animator and then the transition system runs it. So there's a lot of stuff that we just ship with the framework for free and you can simply use implicitly when you run a transition, but if you want to create custom transitions, fairly straightforward to do that. Okay, so now you've got your scenes, you've got your transitions. How do you actually change scenes? How do you go from one scene to another? You could just enter a scene. There's no transition involved there. You're basically just saying, here's the scene I want you to load, and it will do that. It will run the code that was in your runnable. It will inflate the layout resource file that you gave it, whatever. It'll enter the scene. Nothing much going on there, certainly no interesting animations. Or you can tell the transition manager to go to a scene, and in the process of doing that, it will use a default transition along the way. It'll say, okay, I'm going to change into this scene, and in the meantime, I'm going to capture start values, capture end values, and run the default transition for the system. Or you can run it with a custom transition. You can say, okay, I've defined this lovely transition that I want to use when I'm going between this particular scene combination, and now go ahead and transition using one of the transition to or the go methods in the transition manager, and it will actually load that new scene and then run your custom transition along the way. Before we get to transition simplified, there's one other thing that I haven't mentioned here, which is the idea of a transition manager. You'll usually use this just for a one-off thing where you say, transition manager, I want to go to this scene and use my custom transition here. The other thing that it can do is keep a whole graph of information about all the transition combinations that you want for all the scene combinations that you have in your application. We'll see a little bit of that in the demo later. But I did want to point out one final thing here on this last exciting slide is that, with all this information, all these different classes to think about, and you've got scenes and you've got transitions, but really the idea was to make animation simpler for most development cases. So in general, the only method that you probably are going to care about is this one. You call it Transition Manager Begin Delayed Transition, and then give it the scene root that you want to run the transition on. What that does is kicks in all of the process that is going to capture the current values, and then it's going to spawn a layout and rendering run, and then in the middle of that frame, it's going to capture the end values, figure out where things are, and then run an automatic transition for you. In most cases, this is all that you actually care about. It's basically a dynamic change. You can think of this as creating and animating a dynamic scene. So instead of having these pre-baked scenes from layout resource IDs, you can basically say, okay, I want you to run a transition, so get ready, and then in the meantime, I'm going to make a bunch of changes. And then by the time those changes have actually kicked in, measure and layout has run, and the system is ready to draw the new frame, then the transitions kick in, figure out the deltas, figure out the changes, and create the animations and start the animations running. Fairly straightforward, one line of code. Nice. Okay, so now let's take a quick look at a demo. And this is one of the API demos that ships with KitKat. So I would encourage you to download this from the samples, and you can run this and play with it to your heart's content. Totally complicated and interesting demo. So we've defined 4 scenes here. And the scenes use custom views, so no particular reason why. These could be buttons. I happen to make them colored rectangles instead. So as we change between the scenes, you can see we're resizing, we're repositioning these things, and we can just change on the fly. We're canceling, we're interrupting, we're running other transitions. So fairly straightforward. Now let's take a look at the code for that demo. So there's a few different pieces here. First, there's some layout files. So we have transition scene 1. This just has a layout, and it has 4 views inside there, positioned appropriately. Transition 2, scene 2 looks very similar to that. It's just different sizes and different positions for the colored rectangles. Transition 3 adds the complication of also having those grayscale custom views in the middle there. So nothing really interesting going on in the layout resource files, but you'll see them referred to later in the resources that we inflate for the transition manager. We have some custom transition that we've defined. This is simply a change bounds, nothing really interesting here. It's just the standard change bounds that we're going to run. But we refer to this resource later when we inflate the transition manager. Here's a little bit more interesting one. This is a transition set. It's going to run in the default mode where all the transitions run in parallel. It's going to run a change bounds at the same time as it's going to run a fade transition. And the fade is going to be targeted at a specific view, and we use IDs to associate with views. So that means the fade is not generally applied to everything on the screen, but we're saying, hey, I want you to run this specific transition on this specific view in the hierarchy. Fade out is very similar, although in this case it's going to run the transition sequentially. So it's going to run the change bounds on any things that change position and size, and after that's done, it's going to run the fade. And then finally, we have a transition manager, which we haven't really seen yet. This is the object that keeps a graph of what you want to happen as you go from scene to scene in your application. You can define here, I mean, if you don't need any custom transitions, then you wouldn't care about Transition Manager, you would just run transitions. But if you care that when you go from scene 1 to scene 2, you want this particular custom transition, but from scene 2 to scene 3, you want a different one, this is how you would define it, at least in resource files. So you create a Transition Manager, and then you have several transition objects that define the interaction that you want in any of these particular scenes. Scene changes. So we have a from scene that refers to a layout file, and that's implicitly going to inflate that layout resource file and create a scene out of it. We have a to scene, same thing. It's going to create a scene from that layout file. And then we have the transition that it's going to refer to in another transition resource file like the ones that we just looked at. So that's all the resource stuff. Now let's look at the code, which is in transitions.java. And in the API demos, you'll see this in the animations directory, and it's called Simple Transitions. And here it is. Not a lot of code going on here. We inflate the transition manager. Well, we get the transition inflator, And then we inflate the transition manager down here, and we also create 3 scenes along the way. And you'll note we're only creating 3 scenes, but there were actually 4 in the demo, and we'll show why in a minute. The only reason that we need the scenes in the code here is that this is where we specify that we're going to transition to a particular scene. We've already told the transition manager what transitions to run as we go scene to scene, and here we're actually getting a reference to those scenes and saying, okay, now I want to move to scene 1, scene 2, scene 3. And we do that down here. When we click on the radio button in the demo, we get a call to one of these items, and we say, okay, transition manager, I want you to transition to the next scene. And it'll load the scene, it'll figure out the changes, and run the transition that we specified in the transition manager resource file that we saw. Finally, there is a 4th scene in there that has nothing to do with these scene objects that we inflated, but instead this is what I referred to before as a dynamic scene, because we're basically changing the view hierarchy on the fly and having the transition manager or the transition system in general basically automatically animate all the changes there. We call the magic method called begin delayed transition. We hand it a scene root that we're going to operate on. We call this helper method called set new size, and basically we make arbitrary changes inside the view hierarchy. This comes in here, it sets some new layout parameters on the views. This will spawn a request layout internally. Things inside the scene root will end up being relayed out and re-rendered, and when that happens, transition system notices that things have changed and it runs transitions automatically. As you saw in the demo, things move around, things resize with this single line of code. So that's transitions. It's a new feature in KitKat. I anticipate it will be worked on more as time goes on. It's fairly straightforward and simple for now, and hopefully, more importantly, simple for you to use to make richer Android applications. Thanks.